Unit 8, Day 3. Today we'll talk about more radicals and special right triangles. So, again, we're practicing simplifying radicals. So, I will demonstrate how to do number 1 with you. Even though we talked about it last class, it's kind of different because there's a -6 out in front, but that is perfectly fine. It's going to stay there. So, again, we're going to take the 48 and factor it. So, first number that comes to mind would be 6 and 8. And then I know 6 can break into 3 and 2, and 8 into 4 and 2. And then the 4 can break into 2 and 2. So I put it back inside my square root sign. Sorry, I forgot to leave the 6 in front. Okay, so whatever's in front stays in front for now. So I have 1, 3, and then 4 2s. And then, again, when I see a pair of numbers, circle the pair. So I have 2 pairs of 2s. One here and one here. Within the pair, one cancels and one comes out. So I have 1, 2 coming out, and then I have another 2 coming out. When they come outside, they multiply with whatever's out there already. So I have -6 out here, so I'm going to multiply -6 with 2 and then another 2. So essentially it's -6 times 2, which is -12, times another 2, which is -24. And then inside the square root, I still have that 3 all by its lonesome. I'm sorry, this 2 is supposed to be underneath this 1, so it's a fraction in front of the square root this time. So you would still break apart 24, and then once you do that, whatever comes outside will multiply with 1 over 2. But let's get into number 4 and 5, which is very different from the previous lessons because we have a radical on the bottom. Whenever you have a radical on the bottom in the denominator, you're going to take that radical, whatever it is, and multiply both top and bottom by that radical. So in number 4, I'm multiplying by radical 5 in both top and the bottom. When you do that, my numerator will now be 15 times the square root of 5. And in my denominator, the two radicals will join together and you'll have 5 times 5 underneath. Notice I didn't do that up top. The reason that didn't happen up top is because 15 is not a radical. It's just 15. So you don't put it inside. Just leave it alone. And so at the bottom, we would have 2 5s. So again, circle them. 1 will cancel, 1 will come out. So when that 1 comes out, it would be 15 radical 5 at the top over just 5. And now I can take the 5 in the numerator, the 15 in the numerator and the 5 in the denominator, and I can reduce those. Because I know 5 goes into both 15 and itself. 5 goes into 15 3 times, into itself once. So the final simplified version would be 3 square root of 5 over 1, or just 3 square root of 5. Let's practice one more. So a number 5, I have radical 12 on the bottom. So again, I would rationalize the denominator, which is what it's called, by multiplying radical 12, both up top and at the bottom. So now at the top, I would have 2 times radical 12, or 2 radical 12, over radical 12 times 12. And then you should realize what's going to happen next. At the bottom, 112 is going to cancel, and 1's going to come outside. So I will now have 2 square root of 12 over just 12. And then I can now reduce the 2 in the numerator with the 12 in the denominator. So I would have 2 go into itself once, and into the 12 6 times. So I would have square root of 12 over 6. But when you look at it, 12 can be factored. So that means I can simplify the square root in the numerator. So 12 factors into 4 and 3, right? And then 4 becomes 2 and 2. So I would now have the square root of 2 times 2 times 3 at the top over 6. So at the top, I have a pair of 2's, so that means 1's going to cancel and 1 comes out in front. So I would have a 2 in front and only 3 inside, and all of that is over 6 still. So that means I can again reduce the 2 and the 6 now. So 2 goes into itself once, into 6 3 times. So the final answer would be square root of 3 over 3. Now we're going to get into special right triangles. We have a square, right? And each square has 4 90-degree angles. So as you can see, 4 90-degree angles. If I take the diagonal of this square, which is this line here, place it in the square, that diagonal will bisect those 2 right angles. So it ends up being a 45, 45, and 90-degree triangle. So this is a 45, 45, 90-degree triangle. This is your first special right triangle. On the pattern, and if you look at your formula chart, you can find the pattern as follows. It'll say something like x, x, x root 2. What that stands for is the side length. So your legs will be x, and your hypotenuse will be x root 2. So for example, let's say one leg is 1. So let's say x is equal to 1. That means this x is also 1. If I were to use Pythagorean's theorem to figure out the hypotenuse, that would be 1 squared plus 1 squared equals c squared, right? And that's 1 plus 1 equals c squared. So 1 plus 1 is 2, right? And now, if I want to find what c is, I would have to take the square root, right? So square root of 2 is equal to c. So that means my hypotenuse would be the square root of 2. So the legs will always be the same because it's an isosceles triangle. Why is it isosceles? Because it has 2 congruent angles. So the legs will always be the same. The hypotenuse will always be whatever the leg is with the radical 2 attached. So I could put a 1 here, but it's not necessary. So let's try another one. Let's say the leg is 2. So that means this leg is also 2, right? So if I do the math, so that'd be 2 squared plus 2 squared equals c squared, right? So that's 4 plus 4 equals c squared. So that means 8 equals c squared, right? And then take the square root of both sides. So I would have to simplify this square root. The square root of 8 would have to be simplified. So 8, we know, breaks into 4 and 2, but the 4 becomes 2 and 2, right? So essentially, you're going to have 1, 2 cancel, and 1 come outside, and 1 stay inside. So you would have 2 square root 2 equals c. And it'll work every single time, just like this, no matter what. So that's the pattern. Again, your formula chart will tell you x root 2. So x stands for the legs, and they have to be the same number. And then whatever that number is, you can find your hypotenuse. So let's practice real quick. So if one leg is 6, that means the other leg is 6. So that means the hypotenuse will be 6 square root of 2, right? Well, on the next one, all they give me is the hypotenuse, right? And we know that hypotenuse is always x root 2. So if I have x root 2 equal to 10 root 4, sorry, ran out of space. As I was saying, if x root 2 equals 10 root 2, and I want to solve for x, I would have to divide both sides by root 2. Because I want to know what the legs are, right? So when I divide by root 2, it cancels on both sides. So x would simply be 10. X being the legs, so the legs are 10. On the next one, if one leg is 5, the other leg has to be 5. So that means the hypotenuse has to be 5 root 2. The next one kind of wants to trick us up, which is fine. They want the leg to be 9 root 2. So that means the other leg is 9 root 2, right? So if I want to figure out what the hypotenuse is, it would be 9 root 2 times root 2, because it's always x times root 2. So that means it would be 9 root 4. And 9 root 4, well, what's the square root of 4, everybody? It's 2. So it would be 9 times 2, or 18. But that's the pattern for the 45, 45, 90. So on number 1 here, they said find x and y. Well, if I look at it, 8 is across from the 45-degree angle. So that means it's a leg. So across from the other 45-degree angle should be the same measurement. So that means y is also 8. X is across from the right angle. So that means it has to be leg times root 2, right? So that means 8 times root 2. In other words, 8 root 2. I'll leave you to do number 2 on your own. Now let's talk about the other special right triangle. So in order to do that, we're going to use an equilateral triangle. And remember, in an equilateral triangle, each angle is 60 degrees. And when I draw the diagonal, which is this line here, it splits that top angle into 30 and 30. So it becomes a 30, 60, 90 triangle. This is your second special right triangle. The pattern, according to your formula chart, is x, x root 3, and 2 times x for the hypotenuse. So, for example, let's say the short leg is always across from the 30-degree angle because that's the smallest. So let's say the short leg is 1. Right away, I would figure out what the hypotenuse is because that would be 1 times 2, or 2 times 1, which is 2. And then the one across from the 60-degree angle will always be leg times root 3. So 1 root 3, or just root 3 for this situation. Oops, that was an accident. Let's try another one. Let's say across from the 30 degrees is 2. So that means across from 90 would be 2 times 2, which is 4. And then across from 60 will be 2 root 3. Okay, so that's the pattern. It's not meant to be hard. Could I find the answer using Pythagorean's theorem? Yes, but why go through all that work when the pattern is so much easier to use? So let's practice some more. So if the short leg, so this is 30, this is 60, and this is across from 90, right? So if the short leg is 5, that means the hypotenuse is 2 times 5, or 10, right? And then the long leg is 5 times square root of 3. In other words, 5 root 3. Now, on the next one, they give us the hypotenuse. That's 20, right? In other words, that's 2x. So, x, if I divide by 2, x would equal 10. So that's your leg. So, because again, it's x, x root 3, and then 2x. That's the pattern, according to your formula chart. So now that I have what the short leg is, I can find the long leg because the long leg is 10 root 3. And let's do this next row, and we'll leave it at that. It gives us the long leg, right? So since they give us the long leg, they are giving us x root 3. So they are telling us that in x's place is 7. So that means x equals 7. So all right, so we found that the short leg was 7. So now that we have the short leg, we can find the hypotenuse, which is 2 times the short. So that means it's 14. So again, please remember these patterns. They will be very helpful and save you a lot of time and headache. So on number 3, again, we're going to find x and y. We have the side across from 30 as 7. And if you remember your pattern, it's x, x root 3, and 2x, right? So we're given x. So now, across from the 60-degree angle is going to be, so y is going to equal 7 root 3 because it's across from the 60-degree angle. And then x is across from the 90-degree angles. I know there's a lot of x's going on, but across from the 90-degree angle is supposed to be 2 times the short leg, so 2 times 7, so that means it's 14. All right, and I will leave number 4 for you to do on your own. But essentially, you're going to draw a equilateral triangle like we started this part of the lesson with, and split it. And you're going to be finding the length of that line. Okay, so finish number 4 on your own. Make sure you take a picture. And this concludes your notes for today.